Next, we will talk about system configuration for the signaling system. In section 1, we talk about the purposes of having the signaling system in a mass transit system. And in section 2, we talk about the methodologies on how to achieve such purposes. And in this section 3, we will talk about signaling system configuration, how we put them together. The basic configuration for the signaling system, regardless of the signaling system being used, being fixed block system or moving block system, the basic configuration would comprise of three main levels of control and command. First, the train level, we would have signaling equipment on board the train. Then we need a mean to transmit the data. We call it data communication signals, which could be radio signals or Wi-Fi signal. And then we have wayside equipment level. After that, the signal will be sent to the OCC or Operation Control Center level. So as I said, regardless of the signaling system that we use, uh, fixed block or moving blocks, the basic configuration for signaling system would always have these three main levels. And this is just a note that the wayside equipment can include what we call computer-based interlocking or CBI to control all the routes and switches. However, these functions can be performed by the wayside ATP and or ATO equipment depending on how the suppliers configure their signaling system products. Also, the function for performed by the ATP, ATO, and ATS equipment can be varied and dependent on how the signaling system suppliers configure their signaling system packages. As in our previous section, we have already discussed the functions for ATP, ATO, and ATS, the standard functions according to the international standards. But as I just said, the function to be performed by the ATP, ATO, ATS will can be vary depending on how the signaling suppliers configure their signaling system packages. Signaling configuration for train control system, we will talk about metro trains. As we discussed before, for the train control system, the system configuration in each level, being train-borne wayside or or OCC, can be varied, but they have to serve the three main purposes of signaling system, namely to determine the locations of the trains, and secondly, to maintain safe distances between trains, and to perform the required signaling functions. To that extent, we will need two main equipment. Uh, Two main equipment would be required for any signaling configuration. First, we need and equipment to determine the locations of the trains and all the occupancy of the tracks. And then we need the equipment to transmit data from wayside equipment to the trains and vice versa from the trains to the wayside equipment. So regardless of the signaling configuration, we do need these two equipment to determine the location of the trains and the equipment to transmit the data from the wayside equipment to the train and from the train to the wayside equipment. For the modern urban or metro lines, they use moving block system or CBTC for the signaling system. And to determine the locations of the trains, they use the signal transmitter like beacons. And for sending the information will be sent from the train to the wayside equipment by way of Wi-Fi signals. And the same way, the train will receive the track status information from the wayside equipment by way of the Wi-Fi signal as well. But for the old metro lines, they still use fixed block system, and they use track circuits to determine the locations of the trains and the occupancy of the tracks. And for data transmission, to send the data from the track circuit to the wayside equipment, they use hardwire connections, mean cable connection to send the data from the track circuit to the wayside equipment. And the trains will receive the track status information from the wayside equipment by way of coded electronic signals sent from the track to be picked up by an antenna mounted on the train. So we can take note the differences on how the moving block and the fixed block systems exchanging the information between the train and the wayside equipment. And for the intercity or commuter trains, there are three international train control system configuration used, namely the European Train Control System or ETCS. Then we have Chinese Train Control System or CTCS, and then Japanese Train Control System or Digital ATC or DATC. ATC means Automatic Train Control. For the European Train Control System or ETCS, actually the ETCS is the signaling system configuration that is part of what they call European Rail Traffic Management System or ERTS. It was implemented to allow cross-border operation through Europe by creating a single standard of railway signaling. You can imagine a train moving from one country to another in Europe. There would need to be a single standard signaling system that they can move through those countries without having to stop and change the signaling system. Actually, this system was developed by by signaling system suppliers in Europe. And for determine the locations of the trains, they use a signal transmitter, but they call European balances or balances to determine the train's location. And as I said, that ETCS is a part of ERTMS. So another part of ERTMS is GSMR, which is a mean to transmit the data. So the balances will determine the train's location, and they will send the information via GSMS or Global System for Mobile Communication Railway. It's like a GSM in your mobile phone with 900 megahertz or 1800 megahertz frequency band. We can compare those to the Wi-Fi frequencies, which is the 2.4 gigahertz or maybe 5.8 gigahertz. So one can imagine that transferring data using Wi-Fi signals would be better. And the ETCS has 4 levels of configuration, namely level 0, level 1, level 2, and level 3. You might have heard that in Thailand, for the red line, they use ETCS level 1. And for all the what we call double track lines in Thailand, they will also use ETCS level 1. So we will see what are the differences between the levels. So this is ETCS level 0. They call it inside operation, meaning that the train operator will operate the train in accordance with the trackside signals, meaning the train operator must look at the wayside signals. And the fixed ballast, we have already discussed in previous sections about the 2 types of ballasts. We have fixed ballasts that will send the train location information to the train. And then we have what we call switchable or controllable ballasts to send the track status to the train. The next section, track status to the train from what they call LEU or line side electronic unit, meaning that for level 0, this fixed ballast will send the location of the train to the ETCS equipment on board the train, and the equipment called LEU or line side electronic unit will send the track status data to the movable or controllable ballast. For controllable or switchable ballast, the data stored can be changed. It's not like the fixed ballast here. The data would be the same, which is the location of the train. So the LEU will send the track status data of the next section to the train, whether or not the next section is occupied or not. And the signal will be sent to this wayside signal. For instance, if the train operator sees green, he can move forward. But if he see red, meaning that he need to stop the train because the next section is occupied. For this level for ETCS system, actually they don't mention the equipment that they use to determine the occupancy of the track. But in Thailand, for instance, the ETCS level 1, they use track circuit to determine whether or not the track is occupied or vacancy or vacant. So, like I said, for level 0, the train operator must look at the track side signals, and if he see green, he can move forward. At this level 0, it is the train operator eyes will be on the track side signal. As I said that already, that for ETCS level 0, 1, and 2, wayside equipment such as track circuit and or Excel counters need to be installed somewhere here ahead of the train to determine the track or the block's occupancy, or we can call it train detection, in order to send the information to the LEU. Then the LEU will send the information to the switchable ballasts here, and this ballast will send the information to the wayside equipment to turn on the lights here, whether or not it will be green if the next section is vacant, or it will be red if the next section is occupied. But I said already that the train detection equipment are not mentioned in ETCS architecture. It is stated in the literature that the equipment for train detection are not in ETS scopes. And for ETCS level 0 and ETCS level 1, they can be categorized as fixed block system. So ETCS can be either fixed block system or moving block system, or even what they call semi-moving block system. But for level 0 and level 1, they are categorized as fixed block system. For ETCS level 1, we call it ATP operation. Level 0 and level 1, they are basically the same. But for level 1, it has ATP function to control the train from overspeeding, etc. So for level 1 ATP operation, like that in level 0, for ETCS level 1, the train operator still operate the train in accordance with the trackside signals, meaning I still on the trackside signal. The train operator still has to look at the trackside signals. But unlike the level 0, the speed of the train will be monitored by the wayside equipment, including ATP function. ATP means automatic train protection, which is one of the important signaling functions that we need to perform. It's one-way data transmission. Is wayside to 10 unidirectional information transmission. The switchable ballast will transmit movement authority M&A. MA movement authority mean how far the train can move forward. The switchable ballasts will continuously transmit the MA information to the train, and the onboard unit on the train will control the train movement based on the movement authority and the line information received. Meaning that there would be, like I said in a previous slide, that there will be an equipment to determine the track's occupancy and send the information to the LEU, and LEU will send information to the switchable ballasts. And the information from the switchable ballast will be sent to onboard ETCS system, and the onboard ETCS system will control the speed of the train in accordance with the MA information received. Meaning that for level 0, basically the train operation will have to operate the train by himself. They have to speed brake the trains by themselves. But for level 1, the train operators still have to operate the train by themselves, but the trains will be controlled by ATP system. Meaning that if the train is overspeeding, like the train operator overspeed the train, the train board ETCS system will notify the train operator to reduce the speed, and all the onboard equipment can activate the emergency brake to stop the train. This is ETCS level 1 according to the literature. But for the SRT red line in Thailand, it is also installed with the ETS level 1 signaling system. However, for the red line ETCS system, a monitor, or what they call driver machine interface DMI, will be also installed on the train in the driver's cab for the driver to view the information. As I stated earlier, that the required function for signaling system are up to the project owner to define actually. So basically, this is ETCS level 1 signaling system, but for SRT, for the red line, they will add a monitor here, the driver machine interface, showing permitted speed, braking curve, etc., or the movement authority function. And this picture show this is the onboard ETCS system. They call it European Vital Computer, and they have the train will have an antenna unit here to pick up the signal. This is the infill ballast. The infill ballast will tell in advance the status of the next track. This is the fixed ballast to send the train information. This is the switchable ballast that will send the movement authority to the train by radio frequency signal, and the signal will be picked up here by the antenna installed on the train, and information will send to the onboard computer. This is to show this is to show other equipment that will be installed on the train. This is such as what they call a juridical recording system (JRU) or just data recording system. Odometers for speed calculation. Drop Droplet radar. This is also for speed calculation. And trains ATP interface unit. This is important because the system need to be interfaced with the braking devices on the train and other related equipment, mechanical equipment. So what I just talk about is the ETCS level 1, but be noted that for the SRT for the red line in Thailand, they also call it ETCS level 1, but they add a monitor or driver machine interface to it to provide information to the driver. But again, the driver need to also look at the trackside signaling system. And thank you SRT for the picture shown here.